Having conquered the 7 seas, nothing remains but the land. True sailors are not interested in the land, of course, but even the most seasoned among them know that some days are for sailing and some are soggy and cold. And soggy and cold this winter was. Confined to the realm of the unkilled, this stranded pirate concocted a car for themselves. Cars can be very convenient, except when it comes to finding a parking spot. But this car will be easy to park.
My idea was to create a radio-controlled car that was completely 3D printed, so having as few parts as possible that are not 3D printed. So the design is based around these two pieces chassis with some holes. Some of the holes, when I designed it, I already knew what was going to be used for, and others I just added just in case, so then if something goes wrong or if I want to change the design a bit, I have some mounting holes that I can attach additional parts to. And I had to split the base of the car in two because that's the maximum size that would be allowed in my 3D printer. And as you can see, then I tied the two halves together with other 3D printed brackets. And then I also use some super glue to keep them together, as they can otherwise slide a bit. I'm going to mount the front wheels now, and they can rotate around the center axis of the wheel. So this is also an improvement of a previous design that I had, where the wheels were rotating off center, and I had noticed that that's really not good. A small 9-gram servo is used to actively steer the wheels. And it seems to work all right. Of course, the wheels and the servo needs to be connected, so I use this 3D printed rod and a small part that belongs to the servo itself, so I can connect them all together, and I can also easily disconnect them if I need to do some repairs. The rear axle is a single axle connecting the two wheels, and then it has a small gear. The gear I was not able to 3D print myself, but I bought a set of very cheap gears, and then I just found one gear that fitted with the application I had in mind. I made a small hole in the chassis to allow basically to have a bit of a bigger gear and allow a larger reduction, so I can use a small, not very powerful motor and still get some power to move the car. This is especially important when the car starts moving at first. Once it catches up speed, you could actually power it directly with the motor, but the problem is getting the car started, of course. You can see the motor is fixed very thoroughly to the chassis. So I have 4 very long screws, and then there is an additional bracket connecting to that. And this is because I already investigated a few different motors, and this was the one that worked best. But in this way, basically, I could have a separate, like I could only print a small bracket every time I need to change the motor. And now the wheels and the motors are gearing. As you can see, in the end I chose a small reduction, so the gear on the motor and the gear on the wheels are of similar size. This is because the motor was actually powerful enough to get the car moving without much reduction, and then I chose a small reduction so that I could get a very high top speed. Now we mount the electronic into a small electronics box, and basically it's just so that I can fit everything inside and it doesn't fall off the car while it's driving. The box closes with a clicked bracket, like no screws, just clicks into place. And I finally connect the battery to the rest of the electronic system, and there's still a switch that needs to be turned on, so you don't have to power it all the time. Now the whole system is online. Now I'm gonna check. The servo is working all right. Turns very smoothly. And also the motor is acting as it should. So we're all set. It is now time for some testing. Now that Andromeda has approved the testing site, I can start moving the car around. It's not doing too bad. We get a good speed, and it can do these nice drifts. As you can see, it's very easy to drift to the right. You can do donuts. However, when I try to drift to the left, this happens. The car just goes like straight to the left. As you can see, it goes almost on a straight line. And the problem, I think, comes from the fact that when the car turns, the wheels are following a shorter or longer path. And if only one part of the wheels is touching the ground, then one side is easier to turn than the other. Because in this case, if the wheel touching the ground pushes in the opposite direction that you want to curve, you end up going on a straight line. Now, this is not too much of a problem. As you can see, the car goes and it can turn just fine. However, it really turns a lot better one way than the other, and it only drifts in going one way. And I think this problem has to do with the fact that we're using one single axle for the rear wheels, so the wheels that give power to the car. And how do we fix that? Well, in real cars you have a differential gear, which allows the two wheels to that are powered by the engine to go at different speeds while keeping the sum of their speeds constant, so that they can go around the circle and one wheel can go faster than the other. In this case, I was not able to build a differential with the gears I had, but I thought the second best thing was to actually mount two separate motors for the two back wheels to the two rear wheels. The two separate motor can allow the two wheels to go at different speeds, and then I would I would set up the transmitter to give more power to the wheel on the outside of the curve. So, but in general, even if they're given the same power, the motors don't necessarily go at the same speed. If one can go faster, it will go faster even with the same power. So you see here, I connected with a similar bracket two smaller motors. And then I cut the rear axle in two, and I used two similar crown gears to connect to the motors. These motors are smaller, so as you can see, also the gear ratio is higher. So with the car will go slower, but actually the motors are quite fast. So I think this is going to give more or less the same speed as before. The sum of the power of the two small motors is similar to the power of the bigger one. And you see here, when I turn left, the right wheel turns faster, and when I turn right, the left wheel turns faster. And this is something I set up on the transmitter, and it's usually by mixing two channels together. So each motor has its own channel, but actually these two channels are generated by the accelerator and the steering channels. As you can see, I put some weight on the car because that's also an issue. If the car is not heavy enough, the wheels don't get enough traction, and then still one of the wheels will slip, and this also leads to not being able to drift on one side. But now I'm just checking that the car can rotate, and as you saw, it can rotate pretty well. Now, for the final version, of course, I decided I put some weight that I had laying around, and these are dead AA batteries. I made some small brackets also for those. So I put these in, and I can also choose the amount in case I want to experiment with the weight. But in the end, I ended up using all of them. And this is the fantastic cover. It's designed after the best car ever produced, and it will make it a lot nicer. So it just, with 4 screws, it attaches to the chassis, and it looks amazing. You can see now the car can easily drift either way, and it's actually very maneuverable. And we had a small incident. One of the wheels came off. Luckily there were no injuries. And this was all for this car. I think now it's working pretty well. It's reliable, it can turn, it can drift. It's quite fun to play around with. And stay tuned for the next project.